Well, welcome back to another night of review. One of our biggest topics this year is exponential and logarithm problems. So tonight we're going to focus on just identifying exponential growth and decay. So get your calculators handy. So we're going to need this perfectly sketched out in your notebook. Exponential growth functions. Exponential growth occurs when a quantity increases by the same factor over equal intervals of time. So here's my time on the x-axis and my numbers. Notice this exponential growth happens very, very rapidly. Okay, it's not slowly shooting up like a line. It is growing very fast. A function in the form y equals a times 1 plus r to the t, where a is greater than 0 and r is greater than 0 is exponential growth. Okay, so let's jot down what these mean. This y is your final amount. A represents your initial amount. R represents your rate of change. And T represents your time. For exponential growth, the value inside the parentheses has to be greater than 1 because r is being added to 1. All right, let's take a look at exponential decay. Exponential decay occurs when a quantity, you probably guessed it, decreases by the same factor over equal intervals of time. So here's again my time, and here are my numbers. Notice it's decreasing very, very fast. Again, not linear at a constant rate, but very fast. A function in the form y equals a times 1 minus r to the t, where a and r are both greater than 0, is exponential decay. So likewise, the y value represents your final amount. A is your initial amount. R is your rate of change. And t represents your time. Again, take note, in an exponential decay, the value inside the parentheses has to be less than 1 because the rate is being subtracted from 1. Okay, now this is what you covered in Algebra 1. Very, very basic exponential growth and decay. So we're going to start basic, and then we're going to jump into Algebra 2 in the next slide. But let's get the basics out of the way. Determine whether the function is exponential growth or decay, then identify the rate of change. So remember, y is the final amount, a is 5 is the initial amount. The 1 minus 0.07, or 1.07, is equal to 1 plus or minus the rate. Since this number is bigger than 1, we're going to say it's 1 plus the rate. So if I subtract 1, I get 0.07 equals the rate. Therefore, this is growth because it's greater than 1. And I would say it's growing at a rate of 7%. Okay, so hopefully I didn't lose you. This number inside here is bigger than 1, therefore it's growth. How much is it growth by? Well, it's 1 plus the rate. Subtract the 1 over, and you've got your growth rate. Okay, let's try B. Again, 2 is just the initial amount. So I know 0.98 is equal to, it's less than 1, so 1 minus the rate. So I'm going to subtract the 1 over, and I'm going to get 0.02 negative 0.02 equals negative r. Therefore, r equals 0.02, and I would say that growth rate is 2%. Okay, same idea on the next one. So what? They threw a fraction at us. Same idea. Notice the initial amount. You might be thinking, well, there isn't one, but of course there's an initial amount. You have to start with something. What number is there if you don't see it? Well, of course, there's a 1. 1 is the initial amount. So I have 1/2 equals, is this number less than or greater than 1? Well, clearly it's less than 1. So 1 minus the rate, subtract the 1 over, negative 1/2 equals negative r, rate equals 1/2. So I would say it's growing at a rate of 50%. Last easy example, 2 is equal to 1 plus the rate. Subtract my rate over, or my 1 over, so my rate is 1, which means this is growing at 100%. Okay, welcome to Algebra 2. You are not going to see something that simple, most likely. Get your highlighter out. This is what we've got to recognize. Okay, so let's get perfect notes here. Use the power law to make sure the exponent is just t before you identify growth or decay. Highlight that, star that. That is the key. You cannot answer question A until this t is by itself. Let me repeat. You cannot answer whether this is growth or decay until you get this exponent t by itself. And again, we spent weeks doing this. So how do you clean it up? Maybe you don't remember. That's why we're reviewing. So I'm going to say this is really 3 times 1.02. And I can bring that 10 inside. Raised to the 10 times t. Remember, that's legal because power to a power is still multiplying. So all I've really done is move the 10 inside. So now grab your calculator, and you're going to type in 1.02 to the 10th. So I'm going to get 3 equals, type that in your calculator. I get 1.2189, 9442 maybe, raised to the t. Now I can answer this question whether it's exponential growth or decay. Hopefully you're looking inside here and saying, okay, this is bigger than 1. Therefore, let's make a note. We know that it's growth. Now, what is that growth rate? It says identify the rate of change. Well, we're going to do what we just did. It's 1 plus r equals 1.218. Subtract over my 1, and I get 0.22, basically, if I round. So I would say it's growing by 22%. Okay. Now, that was a pretty obvious one. Maybe part B looks a little trickier to you. Let's be smart and rewrite this. This is really 100 times 0.92 raised to the t over 4. If you have to put a number in front of that t, what number would you put there? If I said t over 4, what number is sitting in front of the t? Well, of course, there's a 1 there. So this exponent is really 1/4 t. So I'm going to rewrite this as y equals 100 times 0.92 raised to the 1/4 times t. I'm bringing the 1/4 inside. So now grab that calculator, carefully type it in. And again, what am I typing in? Well, of course, this part, the 0.92 to the 1/4. So I've got 100 times 0.979, etc., raised to the t. Now I can answer the question, is this growth or decay? Well, since my inside function here is less than 1, I know right off the bat that it's decay. So 0.979 equals 1 minus the rate, subtract 1, and I get my rate equals 0.02. Therefore, it's growing at a rate of 2%. Okay, now again, this only works, these videos, if you pause it and try it on your own. So I'm going to give you a chance to try C and D. Okay, rewrite it for yourself, use your calculator, and then go ahead and compare. So again, pause it and try it on your own. All right, so like I said, if you've paused it and tried it, hopefully you've gotten the same thing. So real quickly, I raised this to the 1/2, got my 0.88, said, okay, that's less than 1 decay, and found my percentage that it's decreasing by. Now, this one was a little sneaky because at the moment it's bigger than 1, but when I put that -2 in there, it becomes less than 1. So they're trying to mess with you. This is actually decay because this number is less than 1 once you put it in this t form. And I got a 4% rate of decay. Okay, question 2. The function f of t represents a colony of bacteria over time in years. Determine if the function represents exponential growth or decay. Now again, they're just trying to mess with you. You can't just look at that and tell me you know the answer. You have to get it in y equals ab to the t power. Okay, that t is not by itself, so I need to clean this function up before I dare answer this question. So I've got 10. Now all of this exponent, I'm going to try to zoom in on it, minus the t there, can go together. So I can say it's e to the ln of 200 over 4, all raised to the t. I have to get this exponent, just like we did on those 2 other questions, inside. So now I'm going to go straight to my calculator, and I'm simply going to type in, this piece. So grab that calculator and very carefully type that in. When I do that, I get 3.7606 raised to the t. So now I can be very clear and answer this question whether it's exponential growth or decay. Since this number is greater than 1, I know I have exponential growth. Can I figure out what rate it's growing by? Of course. Well, it's growth. 1 plus r has to equal 3.7606. Subtract that rate, subtract that 1 over, and I get 2.7606. And if I move that decimal, it's growing 200 at a rate of 276%. Now I want you to put a second method in your notebook. All right, so I'm just going to kind of scroll up. This is the mathematical way they want you to show it, but I want you to verify it using your calculator. So I want you to grab your calculator, and we're going to graph this function. So get your calculator, hit y equals, and then let's hit zoom 6. So here's what I got when I graphed it. Okay, I got this beautiful function, and if I just look at it, it's clearly growing. So there's another way to quickly say it's exponential growth if that was multiple choice. Well, let's say you hit zoom 6 and nothing showed up. Well, you can quickly go to your table and look at the y values. What are they doing? They're getting larger. If y gets larger, this thing must be growing. So there's another way to back up your statement to say that you have exponential growth. All right, I've got one more example for you, probably one of the tougher ones even yet. This says rewrite these functions in terms of a monthly growth rate. Let's highlight that word monthly growth rate. So I kind of put some basics down for you. This t here, so let's get these formulas written out. This t represents the time in years. Okay, and now they want me to convert it to a monthly growth rate. So notice what we're going to do. We're going to multiply that t by 12 over 12, and then we're going to pull out the denominator as 1/12, so we have 12t up there, which would be our monthly growth rate. So I'll kind of walk you through two examples. So again, this should all be review, but if it feels new to you, there's a reason we're reviewing. So the question says, rewrite each function in terms of a monthly growth or decay. So I'm going to say that's 500 times 1.12, and I'm going to raise it to the 12 over 12t. Now think of why I'm saying 12 over 12. That's like multiplying by 1. It's not really changing it. It's just kind of converting it to months. Okay, so now I'm going to go one step further, and I'm going to say if I want it to be monthly, then I want to see a 12t here. So I'm going to take that 12 on the bottom and say it's 1.12, and 12 on the bottom represents the number 1/12. And then I'll be left with 12t. And now I'm going to use my calculator, and I'm going to clean up this inside. So I have 500, and I'm going to type in 1.12 to the 1/12, and I get 1.009 raised to the 12t. I now have it, let's make a note, in terms of a monthly growth rate, because I'm taking the years and I'm multiplying them by months. Okay? So this is now a monthly growth rate, and now I can identify, is this growth or decay? Well, again, it's greater than 1, it's growth, and you can easily figure out the rate. We've practiced that enough. All right, so just like normal, you've got one to try here. Pause it, try it on your own, and then I'll have my solutions worked out. But if you don't try it on your own, and you don't get it, that's on you. All right, so real quickly, I wrote 12 over 12t. I want it to say 12t because I want to take that time in years by months. So I'm going to pull out the 1/12, type it in my calculator, 1/2 to the 1/12, and I get now a function in terms of a monthly rate because I have 12 months per year. So I would say right off the bat, whoops, not growth, this is decay because that number is less than 1. And again, you can find the rate. Well, that does it for our first review of exponentials, and we'll have some great practice tomorrow. Have a good night.